Dear students, let's continue our practices on mathematics. So, today's topic is LCD, operations with fractions and exponents. So, what is LCD firstly? LCD, this is least or lowest common denominator. So, I think it's not too hard for you to solve the examples with fractions, with ordinary fractions, especially using the least common denominator, providing to this least common denominator. Let me remember some kind of examples on fractions. So firstly, what's the fractions? You know, it is the number in the form m over n. Here, m and n is integer numbers from the set of integer numbers, where n is not equal to 0, of course. So now, here, we can provide any examples on fractions. So it is, for example, 3 over 4, or just 1 over 2 half. Yeah. So what mean the fraction? It is if we consider, for example, any circle. So for example, you can say it is like cake. Yeah, and let's consider the part. So 3 over 4, it means if you divide by 4 pieces this cake and take the 3 ones, it is 3 over 4. So this we took here, it is 3 over 4. So this is fraction. Okay, now operation with fractions and LCD, least common denominator. Here, for example, very simple example, 3 over 4 plus 1 over 2. How can we add this kind of fractions? Yeah, this is, we need to give here common denominator, least common denominator, and the least common denominator in this case will be 4. So we need to give here to do 4 2, yeah, and 2 plus 3, it is 5 over 4, for example. This is we can write as with integer part 1 and 1 over 4. So now this is very easy example. Okay, let me write a more difficult example. So it is, for example, 5 3 over 8 plus 18 1 over 2 minus 7 5 over 24 divided by 2 over 3. Here I just recall the fraction, the definition of the fraction, and some kind of adding. Yeah. So now in this case, let's do this kind of examples. So here, what we need firstly we need to solve the inside of the brackets, and in this case we need to give the common denominator, least common denominator, to all of them. And in our case, it will be, we have in denominators 8, we have 2 and 24. Yeah, so least common denominator, it is 24 in this case. So it is, let's rewrite 3 8s plus 18 1 over 2 minus 7 5 over 24. You can do separately, for example, the first two and then the third one, or you can do the directly in this case. So it is 24, it's 3, we need to give 3, here 12, and here just 1. Yeah. So now, let's compute the integer part of this fraction. So 5 plus 18, it is 23. And 23 minus 7, it is 16. So 16. And now, let's write the least common denominator. Here we have it is 24. Now, let's multiply and add 9, 3 times 3, plus 12 and minus 5. So it is 16, and here we have 21 minus 5, it is again 16 over 24. We can cancel this fraction, and we have cancel the numerator and denominator. It is 16, and if you cancel it by 4 or by 8, yeah, in this case we can do it. So it is 2 over 3. This is the answer of our example. And now, let me write the next one. So, for example, 1 and 1 over 2 plus 2 and 2 over 3 plus 3 and 3 over 4. Sorry, yeah, we have here the next operation. This is division, yeah? So the inside of this bracket is equal to 16 and 2 over 3. And now we need to divide by 16 and 2 over 3. If we divide, so it is 1. The same expression we get. This is 1. So the answer is 1. This is answer. Okay, now the next example, it is times 3 and 3 over 5 over 40 minus 15 and 1 over 8 divided by 2 1/5. Okay, so what should we do? Firstly, again, of course, compute the inside of our brackets and then multiply. So this is first operation. This is second operation. This one is third operation, division, and this is fourth one, subtracting, and the last one is divide numerator to denominator. This is number 5 operation. So the fraction, it means division, yeah? So numerator divide by denominator. Okay, so in this case, let's write here step by step. First operation, firstly. So it is, so let's add so the common denominator is 12, 6, 4, and 3. So it is 12. Let add firstly the integer part. 1 plus 2, 3, 3 plus 3 is 6. 6 and 12. So here 6 plus 8 plus 9. So it is 6 and in the denominator 12, and numerator is 40 plus 9, it is 23. Or we can write it as 7 and 12. Here we have just 11. Okay, now the next second operation is this is first operation, now second operation. It is multiplying by 3 and 3 over 5. So 7, 11, 12 times 3, 3/5. So it is 7. So let me write in proper fraction. So it is 12. Here we have 7 times 12. It is 84. Yeah. So 14 and 84. 84 plus 11 is 95. and times, here we have 5 multiplied to the denominator, it is 15, and plus 3, it is 18. So now we can cancel them. 18 with 12 by 6, it is, here we have 2, here we have 3, and 95 with 5. And if you divide 95 by 5, it is 19. Yeah. So the answer is 19 times 3. So it is if you multiply them, so it is 57 over 2. Okay, now let's do the next operation, the number 3. So let's write here number 3 here. It is division. 15 1/8 divided by 2 1/5. Okay, so here we have 8. Let's write improper fraction form again. So to multiply and divide, we need improper fraction form. Okay, so if we multiply, it is 14 and 121 divide by, so 5, 2 times 5, it is 10, 11. And now if we divide two fractions, we need to change the second one, so 8 times 5/11. We need to take inverse 1 to this fraction. Okay, 11 and 121 are cancelled by 11 here, and the answer is 55 over 8. And now we need to find the subtracting and then division, this number 5. Okay, number 4. So here we have 14 minus 55 eighths. So it means 14 minus 55 eighths. We can write with integer part. It is like 55 divided by 8. It is 6 and 7. Now, for how can we subtract? We can write 14 as 30 and 8 eighths, and minus 6 7 eighths. So it is 30 minus 6, it is 7 and 1/8. Okay, or it's just, if in proper form, it is 8, 56, 57. And now the last operation number 5. So here we have division, yeah, numerator divided by denominator. This one was numerator. 57 divided by 2 divided by 57 eighths, and it means we need to multiply them by the inverse one, 8 57s, and they are cancelled. This is just 4. So the answer is 4. This is answer. I think it's clear how to solve examples with fractions. And now let's go into the next part of our lesson, and the next thing, it is exponents. Exponents. So how can we define the exponents? It is, for example, if you write any number, yeah, 2 cubed. The 3 is exponent of 2. So here, how can we compute this one? It is 3 times 2, it means, yeah, 2, 2, 2, it is 8. Not 2 times 3. It is 3 times 2. And in generally, if you want to write with the power of n, it is a times a times a, etc. A times a, how many times? N times. So this is a the power of n. Now, let me write some kind of properties of natural exponent of the number. So first, the a the power of 1, it is just a. Yeah, this is obviously. The next one here, a the power of 0, it is 1. So 0 power of any number, it is 1. Clear? Okay. Now the next one, second one, a the power of minus 1, it is 1 over a. Similarly, we can write here a the power of minus n, it is 1 over a the power of n, using this one, previous one. Now, number 3, so the next property, a the power of n times a the power of m. If we have same basis, a, and when we multiply to this expression, we have a the power of n plus m. We need to add the exponents, powers. For division over a the power of m, or we can write just a the power of n over a the divide by a the power of m. It is a the power of n minus m. Now we need to subtract them. Okay, next one, number 5, a the power of a times b the power of n, it is a the power of n times b the power of m. It means to all of them we need to do these powers. And the next one, division. Similarly, it's also equal to a the power of n over b the power of n. And the next one, it is a the power of n the power of m. It is a the power of n times m. In this case, we need to, if it is power in the power, it is product of these two powers. For example, let's do example in this case. It is, for example, 2 the power of 3. Let me write the color. 2 the power of 3 times 2 the power of 2. It is 2 the power of 5. We need to add them. If we have here 2 the power of 3 divided by 2 the power of 2, it is just 2. We need to subtract the powers. Yes? And in the next case, so if we have here a the power of n times, so n and m, it is 2 second, is in third, it is 2, 3, 2 times 3, it is 6. So this is properties of natural exponents. Now let me show some examples. For example, let me write any example here. So 5 the power of 3 times 5 the power of 2 over 5 fourths, for example. Yeah, so it is if we multiply the numerator, it is 5 3 plus 2 and over 5 4, or 5, because they have same basis. If we have same basis, this is correct. 5 the power of 5 over 5 the power of 4. If we divide them, we need to subtract the powers. So it is 5 minus 4, it is 1, just so it is 5 first power, or just 5. The next example, for example, 72 6 times 6 power times 24 fourth power over 36 8th power times 8 third power. Okay, what should we do here? Here we need to divide these numbers to prime numbers. So, for example, in this case it is like 2 and 3, yeah? So we can divide by 2 and 3 this as divisors. So 72, it is 8 times 9, or we can write 8 as 2 cubed, and 9 we can write as 3 second squared, yeah? And all of them in 6 power. Times 24, it's like 8 times 3, or 8 again we can write 2 third cubed times 3, and all of them in 4th degree. Over 36, it is 9 times 4, or just 4 it is 2 second, 93 second, and all of them in 8th power. And 8 it is 2 cubed, third power. So is it clear? We can here divide by prime numbers. In this case especially, it is 2 and 3. Okay, now let's continue. So now we will use what kind of property? Property number 5 and property number 7. So a 2 third and the 6th power, it is 2 times, yeah, 18 times 3, we need to multiply them. 3 12 times 2 12 and 3 fourths. Okay, divide by 2 16, just again multiply 3 16 and 2 9. And now we can do groups with 2 and 3. Okay, let's write 2 and what powers it will be. So in 2 we have 2 18s in top and 2 12s. So it will be 2 third. And the 3 is 3 12 times 3 4. Again we need to add them, and it is 3 16. Okay, now in denominator we have again 2 16 and 2 9. So if we add them, it will be 2 25 times 3 16. And now we can cancel them. And here we have same ones, so they are cancelled. And in this case it is 2 third over 2 25. We need to subtract now the powers because we have same base, and it is 2 5th degree. So this is our answer. Okay, now let's write the next example. So let's continue this topic and write the next one. So 5 times 2 32 minus 4 times 2 30 over 4 times 16. Okay, and now here again we need to consider it is as 2 powers and others. Okay, so it is, we can continue here. 5 to 32 minus 4 we can write as 2 second times 2 third over, in this case 4 it is 2 second degree, yeah, and it's 16 degree in. Let's continue. So here we have 5 times 32 to the power of 32 minus 2. So now we have same base and we can add them, and 2 plus 30 it is 32 over 2 times 32. We need multiply them. Now we have like terms 232, 232 here. We can factorize it, and 232, take out the brackets, and 5 minus 1 over 232. And now we have same expressions, we can cancel them. And it is 5 minus 1, it is just 4. So the answer of our example is 4. And now, let me write the next example. So, here, 110 the power of 6 times 77 power of 4 over 55 power of 8 times 154 the power of 2. Okay, now how to solve this example now? Okay, again divide to prime factorization, and it is 110, it is 11 times 10 or times 2 times 5, yes, and all of them in 6 degree. And 77 it is 7 times 11 and all of them in 4th degree. And now divide by 55, it's 5 times 11 times power of 8, and 154 if you divide by 7, 154 it is 21, yeah, and 7 times 21 it's 7 times 3 times 7, or we can write as 49 times 3 it is, yeah, and all of them in squared. Okay, let's continue. And now what we get here after this one, so it is now 11 6 power times 2 6 times 5 6 power times 7 4 times 11 4 using the properties of natural exponent, 5 8 times 11 8, and times here 7 squared, and squared times squared it is 7 fourths and 3 second. Okay, now let the groups. So here we have 11s. 11s it's in this case 11 6 and 11 4. So it is 11 10. Now 2 6 5 6 7 4 over, here we have 11 8. So 3 sorry, here it's not correct. 3 it is not 3 times 7, it is it is 22, yeah, it's 22, sorry. 22, it's 2 times 11, sorry, 2 times 11 here, yeah, correct. So it is 7 squared and 2 squared and 11 squared. 11 squared. And now here we have 11, what degree? 10th degree again, because we have here 8 and here 11 second. We have 11 10th degree, and 2 second and 5 eighths and 7 second degree. Okay, if we continue it is equals to, let me move to this part, and it's equals to, they are cancelled, 11 tenths and 11 tenths. So here we have 2 squared, not 6, it is 2. 6 over 2 squared, it is 2 fourths degree. And then 5 6 over 5 eighths, we have here minus 2, so it means divide by 5 2, divide by 5 2. So then we have 7 4 7 2, it is 7 2. So the answer is 2 fourths degree times 7 squared times over 5 squared. This is answer. And now let's move to the next type examples. So let me write the following example. In which A, the following equality holds. So it is, for example, A to A. It means this is 4-digit number. So A to A. For example, 1121. For example, and plus 28A equal to A402. Question: in what A the equality holds? So first, 4-digit number plus 3-digit number equals to 4-digit number again, and we need to find this number A. So how to find this number A now? When we adding two numbers, we can write it by columns. Yeah, A to A plus 28A. And getting A402. Okay, here it is. If we add A to A, it is 2. And in this case, yeah, A to A, it is 2. And when it's true, what kind of number if we add? See, what kind of same numbers, yeah? To itself, number to itself, and we get 2. For example, it is 6 plus 6, yeah? If you 6 add to 6, it is 12, and the last digit is 2 here. But if it is 6 plus 6, it is 12. We have 1 in mind, so 2 plus 8, it is 10. With this 1, it should be 1 here, but here we have 0. So the next ones, what kind of ones again we have? Yes, it is 1. 1 plus 1, it is 2. So it is 2, and 2 plus 1 is 10. So it means in this case we have A is 1. Let's check it. So 1, 1, 2, 1 plus 2, 8, 1. Yeah, we replace A by 1 just. And it is 2, 0, 3, and 4, and 1. Is it correct? Yes, of course it is correct. Okay, now the next one. For example, 2A B6 plus B702 is equals to A, B, 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 and A. Let's again check with columns. 2ab6 plus b702, it is ABBA. So 4-digit number plus 4-digit number and getting 4-digit number. So 6 plus 2, it is 8. So it means A is 8. It's very easy now. So and what we have here, A is 8. Now we can find B. So if A is 8 and B plus 0 is B, here we need to put instead of A, 8. 8 plus 7, it is 15. So it should be B is 5. Let's check it. So 2 and A is 8, B is 5, 6 plus 5, 7, 0. 2, let's replace A and B. And what we get here, it is 8, it is 5, it is 15. And 2 plus 5, it is 7, and with 1, it is 8. So it is correct. And the next one, for example, 5-digit number B0008. Let's write by column directly. Minus CC equals to, so it is C C0 and C. Sorry, like this, yeah. It is 4-digit number. This is 4-digit number. So 5-digit number minus 2-digit number, we get 4-digit number. And when it's correct, if B is 1, it's beginning with 1, 10,000. So, and the next type, 8 minus C, it is C. And when it's correct, if C is 4, because 8 minus 4, it is 4. So, and now let's check it. Is it correct or not? Let's check it. 10008 minus, yeah, we can, yeah, sorry, we have the another one also. If it is 9, see, we get again 9, see. So it can be 4 or 9. Let's check with 4. If we put 4 here, we have, it is 44, yes? So 4, and but we don't get here 0. We'll not get here 0. So it's 9. 99 here. And if we check it, it is 9. 9 minus 9 is 0. And here 9 and 9s. So the answer is 9,909. Okay, the next one now. Let's find for the next one. For example, which one? Okay, this one. ABC, again, ABC, this is 3-digit number, plus MN, 2-digit number, getting F, E, D, and P, 4-digit number. So when it's correct, and find F, the power of M plus N, plus A, the power of F. So, how to find this one? Here, it's obviously, we get here F is 1, because it is 3-digit number plus 2-digit number. And if we add them, we don't get the number which is greater than 1,999, because it is 3-digit number and plus 2-digit number. So it will not 1,099. it is f, it means f is 1. So, and 1 in any degrees, it is 1. So this is equals to 1. And now yeah, we said a had to be 9, because when we adding 3-digit numbers with 900, we can get the 4-digit number. If we add, for example, 800 something to 2-digit numbers, we'll get 900 something. So it means a is 9. And 9, the power of f it is 1, it is again 9. So if we add them, it is 10. And now the next one, so a plus ABC, 3-digit number, plus DEC, 3-digit number again, and we get F, 4-digit number, which is equals to FKMC. So again, we have F is 1, obviously, like as previous example, because 3-digit number plus 3-digit number, it is 1. I mean, beginning with 1,000 something it will be, not 2,000. And here we need to find F, A plus B, B plus D, C power. So F, A plus B, it is just 1, because 1 in any power, it is 1. And now just find C now. So what is C here? ABC plus DEC. C plus C should be again C. And when it's correct, C plus C again C. It's correct when it is 0. 0 plus 0, it's again 0. Okay, so it's only correct for 0. So, and it is 0 power, it's again any number in 0 power, it is 1. So if we multiply them, its answer is 1. The answer is 1. And now let's consider the examples on finding last digit. So it is a very important question. How can you find the last digit of number if it is in the form, for example, 2 the power of 2020? For example, can we find the last digit of this number? Because this is a very big number, yeah? But the last digit we can find without computing this power. How? For this, let's recall the two powers. So 2 first power, it is 2. 2 second, it is 4. 2 third, it is 8. 2 fourths, it is ends with 6. We need the last digit of this number, not whole number, just last digit. And 2 fifths, it is 32, so it ends with 2. 2 sixths, it is 64, and it ends with 4. Look here, what we get here? 2 4 6 8 6 2 4. The next one is also 8 6 and 2 4 8 6, etc. We have cycle of these 4 numbers. 2 4 8 6. So this is cycle of these powers of 2. And now to find the last digit of this number, we need to divide this power to the number of cycle. So how many times it will be returned to the... Here we have 4. Yes, this is 4. After 4 times, it's returned to the first one. So 2020 divided by 4, and it is 20 divided by 4, it is 5. 20, 2, 0, 25, 505, and the remainder is 0. We need this remainder to define the last digit. If the here remainder is 1, we should take the first degree, so it will be end with 2. If the remainder is 2, we take the second one, 4, so this number ends with 4. If here remainder is 3, then we need to take the third one, 8, so the following number ends with 8, for example. If the remainder is 4, 4 not will be 4, yes, it will be 0, because we divide by 4. It cannot be equal to 4, our remainder. So it can be 0. If it is 0, we need to take the last one in cycle. So here the last one is this one, 2/4 degree, and it ends with 6. So it means this number ends with 6. The last digit of this number is 6. Is it clear? So if in remainder is 0, so it's divisible. So we need to take the last digit in cycle. Okay, now let's consider the next example. For example, 43, the power of 43. How can you find the last digit of this number? Here we need to consider the last digit of base, so it is 3, and the 3, the power of 43 now we will consider. Not 43, now 3, the power of 43. And again, let's recall 3 power, 3, 1, it is 3, 3, 2, it is 9, 3, 3 ends with 7, 3, 4 ends with 1, 3, 5 ends with 3, 3, 6 ends with 9, etc. Yeah. So here you have again the cycle is equals to 4. 3, 9, 7, 1, 3, 9, 7, 1, etc. So it means 43 we need to divide by what? By 4. So 1, 4, 0, 3. So the here we have 10. So it should be 4, and the remainder is 3. The remainder is 3. Okay, so if the remainder is 3, it will be, in this case, 3, the power of 3 is 43. It is ends with, we need to consider the third one now, because the remainder is 3. If it is 3, we need to consider the third one. It is ends with 7. So it means our number is ends with 7, and it means the 43, the power of 43 ends with 43, power of 43 ends with 7. We just find the last digit of 43, the power of 43, not totally whole number. We find just the last digit. So now remember, if we have bases, here I will write, if we have bases 2, 3, 7, and 8, the cycle is equal to 4. If we have 4 and 9, the cycle is 2. after 2 digits, they are returned. So, and the other ones, 0, 1, 5, and 6, they're one cycle. It means 6, any power ends with 6. For example, 126, the power of 138 ends with 6. It is very easy now. Because 6 times 6, it is 36, or 5 times 5, it is 25. Okay, now, I think it's clear, and now let's continue and next section. And the next examples connected with fractions now. And now let's consider the following sum of the numbers, fractions. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, etc. The next one, for example, 1 over 4 times 5, 5 times 6, etc. And the last one is 1 over 99 times 100. So how can we compute such kind of examples? So in this case, it's very hard to give a least common denominator and adding these fractions. It's very hard. It's very difficult. So there we have the easy way. So let's write any ratio. For example, 1 over a times b. We can write such kind of ratio as 1 over b minus a times 1 over a minus 1 over b. Why? If we subtract them, we will get the common denominator. Here it will be ab. So it is b minus a, and they are cancelled, and we have just 1 over ab. So now we'll use this equation. This is what we as formula. This equation, and replace these fractions. So it is 1 over 1 over 2. It is 2 minus 1. And here 1 over 1 minus 1 over 2. The next one, it is similarly 3 minus 2, 1 over 2 minus 1 over 3, and plus, so let's write here plus, for example, 1 over 4 minus 3, 1 over 3 minus 1 over 4, etc. The last one, 100 minus 99. Here we have 199 minus 100, 1 over 99, 1 over 100. Okay, now we can open our brackets, and we get here. So this is equals to 1. It's equals to 1, 1, 1. So difference is 1. So we can just take out these ones, and we have if we can take this if they are equals. If we have here 2's, we need to take out this 2, 1 over 2. If we have here 3, so difference is 3. It will be when we're factorizing, the 3 will go to the out of these brackets. Okay, now it is 1 over 1. It's just 1 minus 1 over 2. The other ones are 1's. Plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 99 minus 1 over here, etc. Of course, 100 and 100, 1 over 100. Here in the middle we have numbers till 99 times 100. Look here, what do we get? Minus 1 over 2 plus 1 over 2, they are cancelled. Minus 1 over 3 plus 1 over 3, they are also cancelled. And similarly, they are cancelled till 199. The previous one was because minus 1 over 99. So the last one, it is 1, the first one we have without cancelling, and the last one we have. So the answer is 1 minus 1 over 100, or 99 over 100. Okay, the next one now. So next one. For example, here we have 1 over 15 plus 1 over 35 plus 1 over 63 plus etc. plus 1 over 195. So what we get here, we can write this expression as 1 over 3 times 5 plus 1 over 5 times 3 plus etc. plus 1 over, the last one is 30 times 15, 195 it is. And if we continue, so let's use again this equality, and we have 5 minus 3 times 1 over 3 minus 1 over 5 plus 5 minus 7 times 1 over 5 minus 1 over 7 plus etc. Okay, I think it's clear. And the 15 minus 30, 1 over 30 minus 1 over 50. Okay, and now we have the next one. So we have here 2's, 5 minus 3, 5 minus, so 7 minus 5 here, yeah. 7 minus 5, and the next one is 9 minus 7, etc., etc. So we have here the difference is 2. So we can factorize it and take out this 1 over 2. And then inside we have 1 over 3 minus 1 over 5 plus 1 over 5 minus 1 over 3. And they are equal. Is it clear? They are equal. And etc. The last ones are 30 minus 150. So here again we can see they are cancelled, and we have just first one and the last one. 1 over 2, 1 over 3 minus 1 over 15. If we give a common denominator, it is 5. So we can write as 1 over 2 times 4 over 15, or just 2 over 15. This is answer. Okay, next type of examples. Find all integer numbers n that the fraction, the following fraction, is natural number. So in this case, we need to define the integer part of this fraction. So to find the integer part, we need to divide separately to the denominator, and it's equals to 16n squared over n squared minus 128 over n squared. And here we have 16 minus 128 over n squared. Okay, now we need to define all integer numbers that the fraction is natural number. So if we check it, let's check it. And if n is 1, it is 128, because 128 over 1. So n 16 minus 128, this is not natural number. So n is 1, it's not correct. The next one, n is 2. If you put here 2, it is 4, and 128 over 4, it is 32. And it's not also correct. 16 minus 32, it's not integer number. The next one, n is 3. Can we write here 3 or not? Is it the divisor of the 128? So if you put 3, it will be 9, and it's not the divisor of 128. We need to find from divisors of 128. It's not correct. Okay, now n, it can be n is 4, for example, and it will be 16. If n is 4, it is 16, and if you put 16 here, it will be so 8. Yes, 8. It is 8, and 16 minus 8. Yes, correct. It is 8. It is natural number. So if n is 4, it is 16 minus 128 over 16. So it is 16 minus 8. It is 8. It is correct. And the next one can be 8. If it is 8, it is 64. And it's 2. We get 2 here. So 16 minus 128 over 64. It is 2. 16 minus 2, it is 12. And this is also correct. So this is also correct. But other ones, we don't have any other n's. We have just 2 n's. It is 4 and 8. And let's write the next example. 5 the power of 5n the power of 4 plus 4n squared plus 16 over n squared. So here again we need to divide numerator to denominator, and we get 5n squared plus 4 plus 16 over n squared. And find all integer numbers m such that the fraction is natural number again. So this is natural numbers always, and it's enough to find when it will be natural number. This one, 16 over n squared. For what n? So 16 over n squared, if n is 1, it is natural number. If n is 2, it's also natural number. We need to find from the divisors of 16. It will be 4. And for 3, it's not correct. And for n is 4, it is correct. It will be 16. And that's all. So we have 3 values of n. And the last one, so 4n minus 8 over n plus 1. Again, find all integer numbers, and that fraction is natural number. Here again we need to define the integer part of this number. How? We can write 4n plus 4 minus 12 it is. Why we need this one? Because if we factorize it, 4n plus 1 minus 12 here over n plus 1. And when we continue, it's equals to 4 minus 12 over n plus 1. And now we need to find from divisors of 12 this n plus 1. So it can be, if we put instead of n 1, it is correct. But if we put 1, it will be 1 plus 1, 2, and 16 over 2, it is 6, and 4 minus 6, it's not natural number. So this is not correct. N is 2. If n is 2, it is 2 plus 1, 3, and 12 over 3, it is 4. 4 minus 4, it is 0, and it's also not correct. 0 is not natural number. And n is 3. This is correct because 3 plus 1, it is 4. 12 over 4, it is 3. 4 minus 3, it is 1. This is correct. And the next one, for example, n is 4. Now we have 5. N is 5. If n is 5, it will be 6. And 12 over 6 is 2. 4 minus 2, it is 2. It is correct. And the next one is, the next divisor is 12. So n should be 11. If n is 11, 11 plus 1 is 12. 12 over 12, it's 1. 4 minus 1, it is 3. So it's also correct. So how many n's we have? We have 3. N is 3, n is 5, and n is 11. So it was the last example for today. Next week we will continue our practices. Thank you for your attention.